Right then, so on the bench today is a little something I'm working on. Wonky schematic and revisions to schematic and additions to revisions to schematic, as it goes. So you're building a valve amplifier for a friend. It's going to be a bit of a hybrid. It's using some old Russian versions of the 6v6 GT, which is the I can't bloody remember off the top of me. Anyway, it's the Russian Soviet equivalent. So I've not really bothered filming much of it. I've been building it. I've got a picture of this in testing. So it's going to use regulated power supply. So this is a feedback circuit. It's basically the RF540 MOSFET here. When there's no load, there's about 300 volts DC. The potential divider network here, Zener diode and some transistors. When there's about 200 volts at the output, these get triggered, turn on, start stealing dry voltage away from the MOSFET. So yeah, RF540 can just stand it because there's actually only ever 100 volts across it, even when it's unloaded, and that's just at the point the junction in the transistor starts to break down anyway. So even if it did rise slightly above that, all it would do would pass a small bit of current. It wouldn't destroy it. It's just not high enough a voltage. But under normal use, the power supply drops quite a lot. I actually made a bit of a mistake making this. I remember when I was testing the power supply with light bulbs before I built all this, it was a couple of months back, and under load it drops to about 230 volts. Well, of course I set this at 250 volts regulated. Well, if the input voltage is lower than the output voltage, it can't regulate. So I remembered now I was going for a low voltage design. The valves in operation are only going to have about 180 volts across them, which is fine. They can handle that. It's only for a friend's studio. It's only going to be on in the background. It doesn't need to be overly powerful, so a watt or so of lost power isn't going to hurt anything. So yeah, I had to make a few revisions. These transistors here are the transistors that steal the drive from the MOSFET, and under no load conditions these have got about 150 volts across them each, and they're dissipating a couple of milliamps. So I did originally have the little MPSA 42s in there, but obviously it dawned on me that they would have burned out. So if they'd been, say, it was turned on, there's going to be a slight delay before the valves start operating. Those would have got very hot and keep repeating that. They could have eventually burned out. So these are fine. These will get warm. They're not going to overheat. Rest of the circuits, 1 watt resistors and stuff. LED is on the output. It just slightly loads it. So even under no load, there's always a load. It also tells me it's working. So yeah, nothing overly fancy. So sort of, that's the basic schematic. It's probably just changed a bit since I drew this, and then obviously you can see I realised that there's going to be a lot of voltage across these transistors, so I just basically put a potential divider chain. So this one is outputting as emitter follower to this one, so it splits the voltage across the two transistors, means I don't have to have high voltage transistors, and I don't have to heat sink them, because if they'd had all 300 volts across them, they'd have been hot. So yeah, that's that. Now the driver board, let me get this. So that's going to be my main power rail. This is going to be my 0 volt rail. So if you notice, those little black plasticky things are definitely not valves. Well, the circuit itself, it's going to be a 6N1P EV as the input valve. That's 47k, not 22. You can see as I've been going through various configurations of the circuit changes, I've been having to scrub out and recalculate what values of resistors I'm going to have for the cathode and feedback, because it's DC coupled. But the driver stage with the 6N1P, it's only going to have about 110 volts across it. So these upper transistors, you can see I've got some maths on this one. So You see these transistors are only going to have 48 volts across them. There's a current sink transistor as well, 44 volts across it. Well, even if I just try to use a resistor here, there just wasn't going to be enough voltage to run these valves either. So even if if I put a low value resistor here and brought this current sink, so it was only running at a few volts being dropped across a resistor here, I'd have still had such a low voltage across a valve. It would have to been running at such low current, it would have been very non-linear. It wouldn't have worked very well as a phase splitter, so I just went, fuck it, I'm going to shove some transistors in here. So yeah, this is why. So it's going to go valve, long tail pair. You can see obviously this is now removed. It's now I've gone for a transistor one. So yeah, long tail pair based around some transistors, and that's then going to run the two output valves, feedback, simple valve amplifier. So again, I've got 15k as a tail resistor. That's going to, so if you simplify the basic output impedance equation for a transistor based current sink or source, you can simplify it. If you've got a high enough value of tail resistor, you can pretty much simplify it to beta over tail resistor value. So let's say in this instance the beta, the forward gain of the transistor was 100. 100 times 15,000 is quite a high value. Well, if it was 100 times 10 times 15,000, it'd be 150,000. So it's going to be about 1.5 meg output impedance. Now, when you bear in mind it's going to only be swinging about half a volt, well, you might as well say half a volt across 1.5 megaohms. That's 1,500,000 ohms. Is such a small change in current, you might as well call that infinite. So as a long tail pair, that will be very well balanced as long as I get these resistors balanced and these, so the voltages are equal and the impedances are equal. It'll be very well balanced at both DC and AC. And yes, then it's going to feed a couple of 100 N resistors, 220 kilo ohm on the input grids to the valve because they're running cathode bias rather than self-bias cathode bias rather than a adjustable fixed bias. And it works out the output impedance of this stage, about 100 picofarads of shunt resistance should tail it off to whatever it worked out as. It was like 100 kilohertz or something it starts. So that will stop the valve, hopefully stop the whole amplifier from turning into a giant power oscillator once I close the feedback loop. Total gain, I think it's about, it worked out about 750 millivolts RMS input signal will drive it to full power output. It's about 6 watts or something. So yeah, anyway, I'm going to crack on with it, and this will be a series of videos at various stages. I don't really have the time to film every stage I'd like to, but you know, it'd be nice to set up a what do they call it, where the phone takes lots of pictures over a space of time. Anyway, you know what I mean. I can't think what you call it, and the word just won't come to me. So anyway, yeah, you know, and you get like a sort of rapid succession of pictures, so you get a rather fast forwarded montage of the thing being built rather than the painfully slow several hours one solder joint at a time thing if you was watching it in real time. So time lapse, that's the word, time lapse. So yeah, anyway, so this is where I'm up to at present. Next stage is just got to cut some solder joints and stuff on this board, and then I'm going to actually test it and make sure everything is working as it should do. Not putting anything else on that board. Oh dear me, so all the grid resistors need to go straight onto the valve anyway, but I'm going to put, all of this is going to be tacked onto some tag strip under the valves on both channels. Keep them off this board. They're going to work better. It needs to be near the valve to work better. I don't want loads of wires connecting all this to the valve when I can just run one 0-volt wire from this board up to the tag strip and then have this on tag strip right underneath the valves rather than 6-7 wires for each bloody channel coming up off this board. It's going to work better this way, and it's going to be easier to implement. So yeah, anyway, another part coming at some point whenever.